But I'll bring everything together, and then at the end, so we'll talk for about 30 minutes, and then we'll have about 15, 20 minutes of like lab work. You can log into the Pipeline Community Edition, or the PipelineAI Community Edition, and actually play with like Redis plus TensorFlow and Redis plus PyTouch. So there's a big Redis cluster out there within Pipeline. It's all running on Kubernetes, all the latest, greatest. So the way that I got involved with the Redis folks is that like TensorFlow is written in C, right, like C++, and Redis is also written in C, which is really convenient. And so what we realized was we could actually import TensorFlow, that C library, into Redis as a Redis module. And I think we'll be talking about Redis modules maybe after this talk. But the short of Redis modules is there used to be just the sort of Redis runtime, which is really good for like leaderboards and caching, if you think of memcache. But before, it was very difficult to actually write any sort of customizations for Redis. The Redis community, specifically Salvatore, the main guy behind Redis, is very, very strict about what goes into the code base. He wants to keep the runtime very tight, very lean. And when you let us developers start to push code into this slim runtime, we're going to fuck it up, right? So yeah, so with Redis modules, this is a way to fuck it up less, basically. There's a nice interface, and there's certain restrictions. And I think, right, like Dave will probably talk about Redis modules and all that in a bit here. So just to be very clear, most of this presentation was actually built by Luca, and he spoke at the Redis conference a couple months ago, which is an awesome conference, by the way. I've spoken in the last couple of years thanks to Dave. Dave got me in. There's this company, Aerobics, is that how you say it? Aerobics, yeah. So it's a bunch of Italian people, which conveniently is where Redis is, or where the main guy behind Redis lives. And so Luca actually used to work for, or I think he still does work, but now he started his own company called TensorWork. So I have TensorWork down in the bottom. You can go Google it and contact Luca. But more about me. Founder of PipelineAI, machine learning AI in production. That's our focus, the ability to sort of bring microservices and machine learning together. So all the fun things I had learned at Netflix and the A/B tests and canary releases, all of this stuff was lacking in the machine learning world. This is kind of a throwback logo slide here. That's the old Databricks logo. I used to work for Databricks too, where one of our most common requests was, okay, we can train a model in Spark ML, but now what do we do with it, right? There's only so much you can do with batch. There's actually quite a bit that you can do with batch, like machine learning, batch training. But at some point, you do want this stuff to be put online and then operationalized through REST services, gRPC services, something like that. Also, I have this training series called High Performance TensorFlow in Production. That's part of O'Reilly. If you're a Safari member, you can get access to it. Okay, so quick poll. And this has been a long time since I've asked this question, but who's new to the Bay Area? Define. Yeah, okay, sorry. You, I'd say the last year. Okay, awesome. Last 5 years. Okay. Yeah, he's been here more than 20 years.
Yeah.
20 years, guys.
Yes, I moved about 10 years ago from Chicago. Yeah, and this is one of my favorite things, obviously, about living here. This is the reason I can't really live anywhere else, is this kind of collaboration happens. And, this is a holiday weekend, and we're all here. This is...
Long weekend, too.
Yeah, whose wife or rather husband is mad that they're here. Yeah, pretty organized, right? Who's familiar with these Redis modules, this concept of a Redis module? Yeah, let's see if a couple people definitely. So we don't really need to know too much about Redis modules, but just know that this is that kind of way for us to customize Redis, which is what's needed for RedisAI. Who here is familiar with TensorFlow? Who's actually used PyTouch? Okay, a little bit less. Maybe MXNet, another one? Nobody, basically. Roger. And yeah, anyone heard of Onyx? ONNX?
Yeah.
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 So Onyx is like PMML, but 30 years later. So PMML is predictive modeling markup language. It's a way to represent your machine learning in a common format that you can then use really different run times. And so fast forward 30 years and neural networks, and now there's something called Onyx, ONNX, and I can never remember what it stands for, but it's basically the same thing. And so kind of surprisingly, TensorFlow support Onyx. So the TensorFlow community, which is Google basically, does not have a strong interest, I guess you would say, in supporting this common runtime. Whereas folks like MXNet, which is mostly Amazon, right, like scikit-learn, right, these other folks want to support Onyx because that's a fast way for them to productionize these machine learning models. Now, TensorFlow has something called TensorFlow Serving that actually was released right around the same time TensorFlow Core was released. And this is a way to take your TensorFlow model and then productionize it. They supported only gRPC for like 3 years, and I think 6 months ago, TensorFlow Serving now supports HTTP and JSON. So before, like, you had to do some weird things when you wanted to make a microservice out of TensorFlow. How about Kubernetes? And Docker, I assume, that's just like asking if you are familiar with water or penicillin or something. How about Kubeflow? Anyone heard of Kubeflow? Okay, so I'll talk a little bit about Kubeflow. Actually have a workshop coming up. I'll show the link to it later. It's in 2 weeks, I think, 3 weeks, where we'll cover Kubeflow. We'll actually install Kubernetes. We'll install Kubeflow. We'll get end-to-end pipelines going. But that's out of scope for this talk. This is more Redis focused. Kind of a bonus question: who used to work for MapR until 2 weeks ago? Yeah, where's Ancha? Back there. Ancha's back there. And then who wants to hire Ancha from MapR? Where is she? Back there.
What's the problem? May I
Yeah, that's the map plot.
Huh?
version of Ancha.
may I have problem?
Yeah, so she was part of a. I was doing this I was building this age guessing model, and I asked her for a couple different pictures of her, and that one came in about 10 years younger than the one, so probably too much information. But okay, yeah. So challenges of deep learning in production. So obviously there's sort of offline training and there's online machine learning. There's also this sort of holy grail, which is online model training, right? Which is you've trained the model, maybe batch one time, push it out, and then sort of incrementally train. And that's something that PipelineAI explores and offers as part of our service. But for the most part, we'll cover both here, and I'll highlight some of the challenges there. We'll also introduce RedisAI. We'll talk about the sort of core APIs, the core architecture, how to operate it, how to monitor, and some other fun stuff. And then we'll talk about the roadmap as well too. So the first version of RedisAI was really built, by these TensorWork and then Abu guys. So it's still like an evolving project, right? But it's so one big thing we'll talk about with the roadmap is Redis streams, which I think Dave's going to talk about as well too. So if you're familiar with how Kafka, you could pull things off of a Kafka stream, make a prediction, and then put the prediction onto another stream. Right? It's a relatively common pattern. It's a bit hokey. People tend to misuse it. They try to put like a request response sort of flow into it from a web app, and that's sort of an anti-pattern in my mind. But okay, so here's a fun little slide. The training loop. This is key right here. So that's where all the magic happens. And so there's data source. This is sort of end-to-end, right? Like everything that's involved. You have to pre-process the data. What we're doing is essentially converting CSVs or Parquet files or something into what's called tensors. Now the word tensor, right, so just think of it as like an n-dimensional array, right? So a scalar is a tensor, right, like an array is a tensor, matrix is a tensor, any kind of n-dimension, it's just a fancy term for like ND array. And then training, we could do distributed training. This is kind of the whole landscape here. We have an untrained model, we're training it. So the reason untrained model is highlighted here is that it's something I like to point out, which is you always start with some sort of random numbers for your weights that you're learning, right? When you're training models, you have an architecture or some sort of graph, and you need to like train weights. You always start with just random numbers, which is basically an untrained model. Now you can deploy that model and get really crappy results, but it's still a model. Okay? You would never put all zeros. That's horrible. Zero is actually pretty significant, so be careful with zero. You end up with a trained model, and then this is really where we're going to focus, which is the target of your model deployment. And now Redis is a target. Okay? So kind of a busy slide, a lot of logos. The short of this slide here is that you have to like productionize your model, and this would be your trained model down here. Model file has to go into some sort of model server, and then now it's accessible by REST or gRPC or a Kafka stream or a Redis stream. So these cloud providers are all over this, and this just happened a couple years ago, right? reInvent, not last year, but the year before, Amazon released something called SageMaker. And SageMaker is more than just model serving, it's also model training, and it supports TensorFlow actually, in my opinion, better than like Google Cloud ML supports TensorFlow, which is surprising because Google is the main contributor behind TensorFlow. So SageMaker is really nice. They keep extending SageMaker every year. This past year, they've been releasing more and more sort of optimizations, model optimizations, better distributed training, right, like better APIs, lots of samples. They have a whole ton of samples, whole ton of like real workshops even online that they've just open sourced. Google Cloud ML is okay. It's getting better and better. It's starting to support more than just TensorFlow. It now supports Scikit, XGBoost, and I think pretty much any sort of arbitrary Python model. So that's Google's offering. There's Azure ML, which I forgot to put on here. I've never used it. I lost my Hotmail password about 10 years ago, and yeah, I haven't been able to log into Azure since then. It's an old girlfriend's name, and I don't want to go back there. So, yeah, I can't remember which one it was. So the runtimes here, really the most common that you'll see with TensorFlow, actually, to be fully transparent, the most common runtime is Python. So people, when they get something that they could execute with Python, they're going to use Python to execute it, and that's usually behind Flask, behind Tornado, some sort of async web server that can support Python. From a development standpoint, there's tons of examples. It's super easy to just annotate your Flask methods and add security with another annotation and all kinds of fun stuff. But it's quite possibly the absolute slowest way to serve your models. And so people solve this by doing the async, Tornado and stuff, or there's Socket, there's an async socket library and all this stuff. But the real problem is that you have to then pickle or serialize your NumPy arrays into C++, especially if you're using TensorFlow or some sort of C-based framework. So it's kind of that classic PySpark thing that always plagued Python, or PySpark users, is that you were always serializing between Python and the JVM. So coming from Databricks, we were dealing with this all the time. People had Python UTFs, and they couldn't figure out why their job all of a sudden was taking 4 days instead of 4 hours. So just know that the closer you can get to C, the better you'll be. And the really easy way to do that is to just jump straight to TensorFlow serving. Now TensorFlow serving is a little bit wonky. The apt-get install doesn't work all the time. And There's a GPU version, but good luck with that. The CUDA library is all set up, and they just switched to CUDA 10, and that's a shit show. That's where pipeline comes in. We actually try to make this easier. Kubeflow, we're actually starting to integrate more and more pieces of Kubeflow into Pipeline. Kubeflow is a Google project, started last year, maybe the year before, where it's Kubernetes plus TensorFlow. That's kind of where it first came from, but it's actually much, much more. It supports like scikit-learn, all the major like machine learning frameworks. So the goal of all of these is to productionize, right? So to get it out of your Jupyter notebook that's running in the lab and into an application. Okay. If you're in the MXNet land, there's something similar to TensorFlow serving called MXNet Model Server. It's pretty good. If you're in PyTorch land, I think you could actually use Onyx. You could export it to Onyx and then use, I think it's MXNet has a good Onyx interpreter. You can now use Caffe with PyTorch. And Caffe is a C-based, Caffe used to be its own deep learning framework, and then now it's just sort of the serving entity of PyTorch, or at least that's my best understanding. Caffe would be the equivalent now of TensorFlow serving or this MXNet model server. I can run PyTorch at native C speed. And then there's this term bespoke, which has taken me about 5 years to understand what it means.
It's just being custom.
It's like one-off custom. Yeah, bespoke.
I heard somebody use it the other day twice in one sentence. I'm like, no.
Yeah, like recursive bespokeness.
Oh my
God. So when you have, so this is kind of this previous slide here. This is one single model server, right? And so obviously when you're at Netflix scale, when you're Facebook scale, or even off your laptop scale, you need something more than that. You need a cluster. You need coordination. This is where Kubernetes comes in. So these model servers are Docker images, but now we want to be able to auto scale them. We want to trigger off of not just system metrics like CPU load and requests per second, right? But also these sort of data sciencey, machine learning type of metrics. So how well is this model performing? Can we auto promote it as the primary model? Here we're actually running an experiment between 3 different variants of a single model. And that's sort of offline batch up here. And that's kind of the batch metrics. So that's one indicator. That's sort of the offline validation. Okay, so we see Model C have the best validation accuracy, 96%. But let's put all 3 of them out there. The current Model A is out there. But let's put B and C out there, because maybe B does better when it's online, right now. So the concept here is, if you're familiar with model training and then model validation, this is typically done batch and offline. Here we're actually extending this validation step to online. So we're not actually considering C to be the best model until it can pass throughput, and latency. So here we see Model C is actually performing pretty well. It's 1 millisecond, 17 millisecond, 99 percentile, and what's the other metric here? Cost per prediction is less. It's 0.0001 per. So yeah, these are real-time metrics that are popping up. And if some of you are familiar with Netflix open source, this is actually one of our dashboards, and that comes from the Netflix Hystrix open source project. So we've extended it to have more sort of machine learning type metrics on here. And then this is in real time for the same inputs, because we're shadowing traffic to Model B and C. And we could actually compare the predictions. So this is live. And this is kind of a fabricated chart here, so it's all perfectly linear. But for the exact same inputs, we're plotting what the outputs are. And you can canonicalize these predictions. If let's say we're making predictions on top 10 search results for a given input query, we can actually canonicalize and compare sets, right? It's just classic Jaccard similarity, something like that, where you're comparing how equal are these sets. And if we're trying to match the current baseline A, C is like performing well here. It like performed well offline, and it's the best performing online. So C is the clear winner, and we can automatically promote this. So some other notes here in text are, we need to like choose something that fits the current technology stack. If it's Java, or a little bit at a disadvantage, Java and TensorFlow are not too compatible. There's ways to do it, but it's kind of crappy. And at the end of the day, this isn't just about language choices. This is about semantics and scalability, different like latency guarantees, right? Because these application teams need stuff done in 50 milliseconds or 10 milliseconds. These things should be able to run anywhere, any size. So this is specifically targeted towards really small devices, not just phones, but small little edge devices, sensors on cameras that have 32K of RAM. And so there's techniques that can be done that what I call sort of pre-production or post-training, actually. So once the model's been trained, there's this step that's between training and production where you can actually manipulate the model, the learned weights. You can quantize them down, you can round them. There's like different ways to make the model smaller to fit on these small devices, but also keep the accuracy relatively high. So maybe you would lose 1 or 2% accuracy, but you can now do the prediction in 1 millisecond versus 10 milliseconds. This is huge. This is like either that model's going to go out in production or it's not, right, because of these things. So with anything, you want to try to remove or like reduce moving parts. Obviously moving data, and utilize resources. All right, so let me jump in to RedisAI. So the way I think of this is that this is a model server that's running inside of your cluster, which is, yes, this is very, very powerful because now we have data locality, right? There's this data that's in the Redis stream. There's this data that is in the cluster. We could actually, train and then predict. So here we'll specifically talk about prediction off of that data without moving anything around. So this is very powerful. There's this new data type that RedisAI gives you. You can define your own. So the RedisAI project creates something called tensor. And I'll show the actual struct here in a second, the C struct. But tensor in, make your prediction. And this is physically using the TensorFlow C library. So you actually import, so during your Redis build, you tell it to actually import libtensorflow.so, and that comes straight from the TensorFlow GitHub. Same with PyTorch as well too. There's libPyTorch .so that gets compiled in. So this is native C calls. No Python serialization, no Java craziness. Also, the other cool thing is it's not just the model, but RedisAI gives you the ability to define not just Torch script, but also just sort of arbitrary Python functions to pre-process the data coming in and then post-process that prediction. So imagine you have JSON, but you need to convert JSON into a tensor because that's what TensorFlow speaks. So you could have a little snippet of code, right? And it's just like a UDF, right? So the downside, of course, is that now you're at Python speed, so you kind of want to reduce that. But it's just showing you flexibility. There's really 3 steps to any machine learning prediction. There's pre-processing the inputs, and then there's making the prediction, and then post-processing the actual prediction, the outputs, and then converting it into the format that the caller's looking for. The other cool thing about RedisAI, which I was actually blown away when I heard about this, is the GPU support. And so, and in kind of retrospect, this is obvious because they're using libTensorFlow, which there is a GPU version that's available. So all they do is say, I want the GPU version of libtensorflow.so, and then link it in, and same with PyTorch, and now you have GPU support. There's also Onyx support on its way. I don't think it's there just yet. In my opinion, it's kind of the smallest piece of the pie. PyTorch and TensorFlow are the largest pieces. So this is where we're at today. keeps data local. Yeah, everything runs within Redis, very cool. There's multiple backends. You could actually define multiple backends for like PyTouch TensorFlow, whatever. Language independent. Keeps models hot, so this is good. You know, once the first prediction comes through, and I can't remember if you can preload or sort of warm up the model. Yeah, I've always had to suffer the initial call, but yeah, so models stay hot, and you gain all the benefits of HA from Redis with Sentinel and all the fun clustering stuff. Okay, so here's the API. Very simple. This is what we're going to do in the workshop here in a bit. We're setting the tensor. So this is the input tensor. There's actually a sort of generic type called the blob. And this is what you would use to do images. And so I'll show you guys, we're actually going to make, we'll like pull in a cat image and then make a prediction with Redis, and it'll tell us that it's a cat. So super easy API, follows kind of the like Redis conventions. And then you would make the prediction here, it's kind of ... and then you would get that result. Here's the actual struct, for all you C heads out there. This tensor is actually based on this DMLC project called DLPack. If you're familiar with like XGBoost, and if you're sort of a hardcore machine learning person and systems level, you'll run across DMLC quite a bit. They're really kind of the like building blocks for a lot of higher level projects. So here's how we actually set the model. So before I was showing how you set the inputs, now we have to set the model. You would typically set the model first, actually, and then you just set the inputs, make the call. So there's tensor set, there's tensor get, there's model set, there's model run, and I think that's it. So here we're defining this model called ResNet. Foo.pt is probably bad. That should be like resnet50.pt. In the examples, it's more clear, but just know that we're taking this blob that we've trained. So this is assuming that we've already trained the model. We're now setting the model name resnet50. We're telling it that we're using PyTorch with that torch command, torch attribute. And then we're saying this is with a GPU. So the one we'll be doing will be TensorFlow CPU. And then also you can define inputs and the outputs as well too. So here's an example. This is actually, I think this is ResNet 18. It's back copy and paste. But yeah, we'll be doing ResNet 50. So this is model run. So you call that, you actually give it the inputs that we had set up here. So we set this tensor name foo. And then calling model run foo, and then we're defining the output variable. This is more on the training side, but so the way, one limitation right now, and this really isn't RedisAI's fault, it's the TensorFlow community. So TensorFlow, just as a total side note, don't get too confused if you don't understand this, they've changed the way that you save models. And at the time RedisAI was being built, the most stable was a protobuf version that is exported with this freeze. There's a way to like freeze the graph. And freezing the graph means taking the sort of network architecture that has no weights, taking your trained weights, and then combining them, so freezing them. So in your model, you had mutable weights because you were training. But now you're telling TensorFlow that it's time to serve this model and make predictions. So you're now converting mutable into the constants that were trained offline. So you would combine those into one PD, which is protobuf, and yes, even this code has changed with like TensorFlow 2.0 actually. But yeah, just know that when you use RedisAI right now, you have to use kind of the older way of save model. And it's part of the like roadmap to actually support the newer state model format. So this is the equivalent, exporting the model. So here's just kind of just like a simple model called random. And so that's actually, oh, and so here's the script setting stuff. So I said before that we have a model, but now we could also set little snippets of code to do pre-processing and post-processing. And so here we are, we're just defining a function. Here it's a Python method called add2. They chose to use txt in this example. I don't know why. It would be .py. And we're now able to make calls, script run, right, like just like we did model run. So we would do script run for the pre-process, we would do model run, and then we would do script run for the post-process, and then tensor again. So I actually don't know too much about Torch script, but I guess more on scripts here, Python-like. Let's see, works with CPU. Yeah, so I actually don't know too much about Torch script specifically. I'll skip that. Okay, and then for those of you that are interested in like lower level details, every like request that comes in, there's a queue for these predictions. This is a Redis module thing or just a Redis thing. And so this like Redis module like framework gives you the ability to create queues and to participate in the sort of processing, right? That like processing loop. So this naturally gives you the ability to do back pressure, keeps like Redis responsive because these queues are isolated, thread pools are isolated, models are hot in memory, and it's the client that would actually block in this case. So the like underlying struct, if you want to go through the RedisAI code, it's RedisAI run info, and this contains the payload. If you're wondering about persistence, so yeah, RDB is supported. This is a Redis thing, RDB. Also AOF, this is also a Redis term, the append-only file. This is coming soon, it's not currently supported. Yes, everything, see, scripts are serialized as strings. So this is more just the typical Redis replication. I'm not gonna spend too much time here. And then for the RedisAI, the client libraries, there's a Java API and RedisAI Python. So this is what we'll be using, RedisAI Python here. They also have Node.js support, it appears. Yeah, who here uses Node.js? And why? Yeah, I've been doing a lot of Node.js recently, and I'm like, how did this ever gain popularity? All right, let's talk about the roadmap. So the sort of high-level gist of this roadmap is faster predictions, less likely to take down Redis, less likely to block the client for too long, participate better in replication, and yeah, the ability to do async. So here, there's this concept called DAG run, where you could do these things, script run, model run, script run. So this is pre-processing, running that prediction, and then post-processing, and actually really create this as one sort of like atomic thing that's happening. There's a way to specify read-only. So if you're familiar with Redis, you want as many like read-only type of operations as possible. This way you can federate. You can do things in parallel. There's no master, rather mutable like data to update. Also, one thing that I kind of brushed over is that we can't really, if there are multiple GPUs, you can't actually like take advantage of that. CPUs are very different. CPUs are handled by Linux itself. So if you have 64 CPUs in your code, rather all you do is just specify CPU :0. Is kind of the TensorFlow way to do it. It's done for you automatically. You would never think about it. In TensorFlow, like you would never isolate and say, I want this to run on CPU 6. You would be fighting like Linux's ability for the thread scheduling. But in GPU land, this is very different. There actually are times when you do want to isolate specific GPUs, specifically in the case where you have this huge like network, this huge neural network, and part of it, it's so big that it can't even fit in the 16 gigs on one single GPU. So now you have to isolate and put certain operations or certain parts of that network on GPU 0, certain parts on GPU 1, and you have to be very careful how much communication happens across those GPUs. So yes, unfortunately GPU programming, CUDA programming is still very barbaric. It's not as easy as we've gotten used to in the CPU land. And then async, of course, is the ability to fire and forget, and then query for the results later, which is kind of cool. And then streams. So this is the one I'm most excited about, the ability to actually operate on a stream and not just specific pieces of data or like specific variables. And I think Dave's going to talk about streams here in a bit. And I was just talking with like Dave before this. We're thinking about putting together a Redis streams type of this like community project where we can start to build things on top of Redis streams and really highlight the power of streams, specifically this like AI stuff. So the Onyx runtime, this is something else on the roadmap here. I'm not going to spend too much time here. Auto batching. So this is one thing, we did this quite heavily at Netflix, where, and actually Hystrix, that one like dashboard I showed with the big circles and the latencies, that actually fed into, how we were able to rearrange certain requests that were taking longer than others, right? Let's say we could, so as request responses are happening, there's heuristics that we're maintaining about these requests, and we can see these 3 requests can actually happen in the same time that one other request in the blue happens. So we would sort of bin pack them, right? Like pack these all together, and then we spent quite a bit of time at Netflix rewriting our backend services to take batches of data so that we can directly take advantage of this type of stuff. So rather versus making single calls and then having latencies all over the board, we could actually batch up a bunch of smaller like requests and then send them in. Huge performance gains. And you can define a batch size by either milliseconds, wait every 10 milliseconds, or 500 like requests coming in. So time to response, yeah, let's see. And then lazy loading, so this comes in handy where right now we have to load CPU and GPU just in case you decide to use them. Yeah, the ability to just load in CPU when you know you can only use CPU. Info, just more like metrics about your predictions. Okay, live demo. If you guys go to community.pipeline.ai and log in, I don't know how much battery I have left, so do it quick. Yeah, community.pipeline.ai. If you log in and go to notebooks, and there'll be a folder for Redis. And it's basically these gets and sets. Pull it up here real quick. Just let me show you the last couple slides here before my laptop dies. So RedisAI, that's the GitHub repo. There's the Docker Hub repo. That's Antje again with her Docker shirt on, flying over from Germany. And this is how you can run on your local laptop. And then there's a workshop coming up June 15th. Quick plug for this, so come on out. It's a paid workshop because we have big servers. There's a rumor that I'm starting that we might actually be using TPUs. It's my workshop, so I can start my own rumors. So we'll be using Google, and Google just gave me a whole shit ton of free TPUs. I don't know why, but they're trying to get people to use TPUs, I guess. So yeah, sign up for this and we'll rock it out. And then, so let me show you this real quick. Yeah, so I'm going to post all the slides will be on off PipelineAI. There's a community tab, And yeah, like you'll see all the like videos. There's probably about 500 videos, by the way. Also, I run a pretty big meetup. Some of you guys might have found this from here, but the Advanced Spark TensorFlow meetup. And it's here in town. We got about like 11,000 members, so come on out. But let me show you the notebook. So here's the notebook. Kill PowerPoint. Yes, I'm also like recording this as well too, and I'll post that right after this. So if you do log into community.pipeline.ai, you'll get to this home thing here. Whoa. And there's a Redis directory. So this is Jupyter Lab, by the way. This is like a thick skin on top of Jupyter Notebook. It's kind of or like a thick theme. It's a pretty well supported project, mainly from the like Bloomberg guys, but also supported. There's a lot of plugins and everything.
I think the lead for this is
Oh, really?
whatever that guy's name is. One of the founders.
For like Jupyter Lab. So the only one I think that works right now is the TensorFlow one. I was trying to get the PyTorch one working, but so let me just close down PyTorch. We have time for the other. Oh, it's not working anyway. But so here's some imports, and there's already a cluster out there. I can give you guys a peek at that. And this is what we'll be setting up, by the way, during the workshop. So here's Community Edition. We have the notebook server. We have a Redis master out here. And the admin is the actual UI for, so this is Kubernetes. For anyone that cares. We're using Ceph on the back end for the like distributed file system. Yes, I want to use MapR, but they closed. So can't use MapR anymore, so I have to go to the open source version. So here we're connecting to the cluster. Because this is a notebook server running in the same cluster as our Redis cluster, we could actually just access it by sort of internal DNS provided by Kubernetes. So we're going to connect, we're going to set input vector. Let me just get to the good stuff here, which is, so here we're actually setting the model. And I've downloaded the model from RedisAI's repo. This is the ResNet model. This has been trained on millions and millions of images. And now we want to pass in our pictures and get classifications. So,
Getting who's the phone
and this is, so that's model set. Here's a pre-processing. Actually, this is one script that we're going to make multiple calls into, pre-process and post-process. It's a .py. Passing that in, so script set. So now from this point on, we can call script run with that name. And then tell it which function within there to call. So here we have a cat picture. We're converting it into a blob, tensor set. We're just using a simple Python library to convert it into a blob, setting it as a blob, and then we're going to plot it. Cute little thing. And then this is where we're going to, so we are setting the blob. We're then calling script run to pre-process. This is basically cropping it down into the format that the model has been trained on. So that's why we have to do pre-processing. And then we're going to then post-process and call script run. So this is a function within that .py file that was up above. And that's another function in that file. And then at the end, we call get. So it thinks it's a tabby cat. And someone told me that that's not actually a tabby cat. So it doesn't look like a tabby cat. But maybe we're all incorrect and the model is right. Who knows, right? So let's take something a little bit more tangible. Guitar. So this predicted encryption. Okay, so the guitar didn't work, but this one, so this is a picture of the creator of Redis. And it predicts so the joke here is that it actually predicts barbershop for that picture of his crazy hair. Yeah, barbershop.
Maybe it's basically trying to tell me he's a haircut.
Yeah, and shaved. Wipe that scowl off his face too. He always has a scowl. Yeah, any questions? Okay. I'll post all this afterward. Thanks for listening.